Welcome surfers, it is Joele and this is Rustlers Atom 2.6. In today's video we talk about NLL, the non-lexical lifetimes. If you haven't subscribed to this channel yet, this can be the perfect time to do it, to support my work. For a long time, the borrow checker was actually a lot stricter than it needed to be in Rust. It operated on something called lexical scope. Basically, if you created a reference inside a pair of curly braces, Rust assumed that reference lived until the closing brace. Period. This is the fact. Even if you were totally done using that variable's lines ago in the code, the compiler would scream at you because the block hadn't ended yet. Since the 2018 edition in Rust, finally we have the non-lexical lifetimes, or NLL. And this was a massive quality of life upgrade for all Rust developers. Let's take a look at a classic example of what we called interleaved borrows. I now write some code that back in the past would have failed. Let's create a mutable data vector. Inside this vector I put 1, 2 and 3 as always in my examples. Now step 1. Create a mutable reference. Comment, no, let mutable ref data equal to mutable data. Okay. In the old Rust, here mut ref data is still alive. And this can be a problem because Rust look the data inside this couple of curly braces. So if, for example, I write something like this, the old Rust would say there is an error here, because data is still borrowed mutably. But it's not true, because after this using of my mutable reference, I don't use it anymore. So this code can be executed. With NLL, the compiler do not have this kind of problem. So if I print in debug formatting my immutable reference, compiler have nothing to say. Okay, some unused variable warning, but the compiler work with any problem and print the content of my vector. This is a very good thing, but there is one massive nuance you need to understand so you don't get bitten by bugs later. NLL change liveness when a borrow is active, but it does not change the scope when when a value is dropped. let's do an example of for understand this difference. Let's create a struct and drop sound that implement the drop trait for drop sound function drop with a mutable self-reference as parameter. Okay, print bang the sound of the drop. Okay, close all the curly braces. Perfect. Now let x equal to drop sound and let y equal to reference x. Okay, I can print use y. Y. Perfect. Thanks to NLL, the Wiseboro and right here. But x is not dropped yet. But here x is dropped at the closing brace. Okay, let's I can print here another message just to understand better the job behind the scene and of main. Okay, so thanks to NLL, y borrow end here, but x is dropped in the same way because NLL do not influence the scope, do not influence when a value is dropped. Let's run all of this. With drop sound. Okay, drop sound. It's written three different ways, not good. Okay, let's try again. Okay, I need the debug to print this. So I can simply drive the debug here. Thanks. Oh, it's the wrong position, for sure. Okay, and now I can simply drop this line. Try again. Maybe is the right code. Okay, we have our vector for the first test. We use y here. The main end, and only after the end of the main, only after the closing curling brace, I have the bang, the sound of the drop. This is the difference between liveness and scope is very important to understand in Rust. So, for this video it's all. See you in the next Atom. Don't forget to like the video, to subscribe to the channel, and to keep always your thinking cap on.